Assalamu alaikum, grade 8. This is the lecture number 4 from chapter number 1, and topic is elements, compounds and mixture. After studying the basic definitions, now we will give a detailed study to these three things, and today we will only study elements. First, we will review the classification of matter. What is matter? Matter is anything that occupies space and have mass. So matter is divided into two types. One is a mixture and other is substance. Mixture is of two types, homogeneous and heterogeneous mixture, and substance is elements and compounds. And our basic topic is today elements. In old times, only 9 elements um, were known. And what are these 9 elements? These are carbon, gold, silver, tin, mercury, lead, copper, iron and sulfur. So, according to the old definition of elements, elements are the substance that could not be broken down into simpler units by ordinary chemical processes. But this was not very very good definition. So, the modern definition is it is a substance made up of same type of atoms having same atomic number and cannot be decomposed into simple substances by ordinary chemical means. So, by heating or by just melting, you can't change the element or decompose it. There should be some complex chemical reactions to decompose it. So, it means each element is made up of unique type of atoms that have very specific properties. So, there is a table and it shows the natural occurrence by weight percent of some major elements. You have to memorize this table. We can see it on earth crust, in oceans and in atmosphere. And oxygen on earth crust is 47%, in oceans it is 86%, and on atmosphere it is 21%. In the same way, silicon in earth crust 28% and aluminium is 7.8%, hydrogen in ocean 11% and chlorine is 1.8%. In atmosphere, nitrogen is 78% and argon is 0.9%. You have to memorize this percentage by weight. Next topic is types of elements. As you know, element matter exists in three forms and elements also: solid, liquid, gas. We will take a few examples of solids, liquid and gases. Solid elements are sodium, copper, zinc, gold, and liquid maybe mercury. You can take a thermometer and see mercury in liquid form, and bromine also. Gas in oxygen, chlorine and hydrogen are very common gases. And other definition related to elements is symbols. We have to study symbols first. Symbols are the abbreviations for the name of elements. We use a short form of an element in chemistry. So a symbol is taken from the name of that element in English, Latin, Greek or German. If the symbol is one letter, then that letter would be written as capital. You can see hydrogen H, nitrogen N, carbon C. And if the symbol is two lettered, then the first letter would be written as capital and second letter as small. Ca for calcium, Na for sodium and Cl for chlorine. Before I will give you the definition of valency, I want to explain the structure of atom briefly. As you studied in previous classes, in center there is a nucleus that contains proton and neutron, and around the nucleus electrons revolve. Electrons have negative charge and protons have positive charge and neutrons are neutral. So the outer shell of an atom, the outermost shell that can donate electron, must have 8 electrons to become an element stable or atom stable. So The outer shell must complete 8 electrons. If the outer shell is not had 8 electrons, it wouldn't be stable and it needs to share electrons with some other atom, and this is also known as octet rule. From the outer shell, an atom donate electron. If an atom donate one electron, its valency would be 1, and if it can donate 2 electrons, and its valency would be 2, and so on. Hydrogen has only one electron on its outer shell, so its valency in all compounds is 1. As you can see in example number 1, it's HCl1. Now we can explain valency and define valency. So valency is the combining capacity of an element with other elements. It depends upon the number of electrons in the outermost shell, and in examples, in covalent compounds, valency of hydrogen is 1, and in second example, valency of oxygen is 2, and in ionic compounds, valency of sodium is 1 and valency of nitrogen is 7. So hope you understand the valency. The next definition is variable valency. Some elements shows more than one valency in different compounds. In ferrous sulfate, the valency of iron is 2, but in ferric sulfate, valency of iron is 3. Uh, and the ferrous and ferric is the Greek or Latin name of iron. So you have to solve the questions related to this topic, and thank you.